Hi, in this video we're going to be looking at combinations as opposed to arrangements. There is a difference, and combinations is what you will be asked to be across in the Math Methods Foundation course, but it does build on from the concepts of arrangements, which is why I started there last lesson. So my definition of a combination is an arrangement with repeats cut out. Because if you think about it, if I go back to the original problem, which was Anna, Brooke, Callum and Dykesy in a race, if we talked about first, second and third, which is an arrangement problem, then we could have Anna, Brooke and Callum finishing in the top three, but then we had to look at all the different possible combinations of those top three. Or we could have Dykesy, Brooke and Callum in the top three, but then we have to look at different combinations of first, second and third here. Or Dykesy and Brooke and all the different combinations that would make first, second and third there, etc. So we end up with 4 different distinct possible top three, but then there are 6 combinations in each one for first, second and third, which is where we get the 24. But conversely, what we can do is we can work out all the permutations using our permutation logic, which is 24, and then divide out all the repeats. So this here all collapses down to 1, this here all collapses down to 1, these collapse down to 1, and these collapse down into 1. That's a top 3 group, that's a top 3 group, that's a top 3, that's a top 3, and that's a top 3 group, because order doesn't matter. So we effectively end up taking our permutations and we divide it by the number of different kinds of groups, in this case it's 6, to get our 4 here. So as a calculation, it makes a lot more sense. So let me go back to our problem here. As I said, when order matters, it's 24. When order doesn't matter, there are only 4 ways to get a top 3. So I've got an example here of the race again, but I've added an extra person into the race to make it slightly more interesting. And that's A, B, C, D, and now we've got an F, and you can figure out who the F might be. That sounds rude. I just mean it's Finn. And let's look at getting a top 3 from there. So I'll draw my 3 here, and we're starting off by treating this like an arrangement. In other words, how many ways can I get someone into first place? Well, if there are 5 people in the race, that means there are 5 ways I can get into first place. And then who's going to be next across the line? Well, there are 4 people that could be in the second place, and then there are 3 people who could be in third place. So we've got 5 times 4 times 3, and that would give us 120. Okay, so 5 times 4 times 3, like so. Now that's not very hard to do by calculation, but imagine it was a race of 120 people, or imagine you're looking at the top 10, then things get a bit more complicated. So just a reminder from last video, we had a way of working out the number of arrangements, and that was taking the factorial of the number of items we have, which in this case is 5 races, or 5 students in the race, and then we divide it by the bit that we don't want, which is the times 2 times 1. So that was n minus r, if you remember. So that's divided by 2 factorial. And again, just to confirm, if I go 5 factorial divided by 2 factorial, I do get my 60, like so. So this is equal to 60 as well. So that's our arrangements here, number of arrangements. So we need some way of determining how to cut out all the like top 3s. Okay, so there are 60 ways of getting first, second and third, but there's plenty of repeats in the top 3. So if you think about it, I guess, when order doesn't matter, ABC, BAC, CBA, etc., they're all the same result. So what we need to divide out are all the similar top 3s. So we have a look at our 3. And we say, I've got my top 3. How many ways could I place someone in the first place from my top 3? And the answer is 3. So I've got my top 3. How many ways can I place someone in the first place? 3 ways. Now that I've placed someone in first place, how many ways can I place someone in second place? 2. And how many ways can I place someone in the first place? 1. So that becomes 3 factorial, and that's what I have to divide out. And so we've got the number of ways would be 60 divided by 3 factorial. Okay, so the divided by 3 factorial cuts out all of those combinations that are repeats or arrangements that are repeats. But 60, if you remember, was simply 5 factorial divided by 2 factorial. So in other words, the total number of ways I can combine things and then dividing out the bit that I don't need. So I can write that as 5 factorial on top divided by 3 factorial, 2 factorial. So this bit is the arrangements. This bit is cutting out the same combinations, I suppose. Okay, and that's how you do a combination problem. You're simply dividing by an extra thing. Now, if you remember, I'm going to put the formula down at some point as well. I'll do it on the next screen, actually. So I'll just go about the notation. How do we describe this? I didn't describe the notation for a permutation because it's not really part of the course. You just need to have a sense of it. But there is a notation I want you to be across. So we've got R objects being selected from n possible objects. So in the case of objects, I don't mean to objectify my students. I'm just talking about the 5 students in this instance. I've got 5 people running the race. That's n. I'm looking for a top 3, so that's R. So that would be, the way we write it is we go 5 C, sorry, I shouldn't use the specifics, N C R. So that means choosing R objects from N. Or, this is the other notation, using big long brackets like this, N and R like so. Choosing 5 from, I kind of like the C notation myself personally because it's like C for choosing or combining. The N goes to the left as a superscript, then there's C, and then the R goes as a subscript to the right. Okay, I haven't got the formula here, so I'll put it on this screen as well. So the formula looks like this. NCR is equal to, how does it work out? This top is N. So it's N factorial divided by, what's this? If you remember from last video, it's N minus R factorial. Like so. And what's this? Well, this ends up being, this is always going to be a combination of how many things you're selecting, which is effectively R, right? So we also divide by R factorial. So the notation is NCR equals N factorial over R factorial, N minus R factorial. Visually, because that's kind of a bit clunky to think about, visually you can see that these two numbers add up to this number here, and they always will. If you think about it, you can figure out why. So this number gets split into these two like so. So you can go 5 N factorial, R factorial, and then subtract these two to get this one here. Okay, so 10C4 is equal to 10 factorial over 4 factorial, 6 factorial. That's how you would write it. You could do it by hand if you wanted to. That's 10 factorial is 10 times 9 times 8 times 7 times 6 factorial over 4 times 3 times 2 times 1 times 6 factorial. I can then cancel out the 6 factorials. I can then have a look for other opportunities like 4 times 2 equals 8. 3 goes into 9 3 times. So just a lot of cancelling down, and then I can go, that is equal to 10 times 3 times 7 on top. So 3 sevens are 21. So I've got 210 is what 10C4 is. But if we do have it in the calculator section, it's a bit easier. We're looking under the menu here, and we're going to go to probability, and there's combinations there. Oh, by the way, that's where factorial is found. I knew it was there somewhere. So there's combinations, and you can see the function is NCR. Then I put in N to start with, which in this case is 10. And then I put a comma, and then I put R, which is 4, close the bracket, and there's my 210, like I wrote. Phew. Let's do 8C0. So that would be 8 factorial over R factorial, which is 0 factorial, and then 8 minus 0 factorial. So it's 8 factorial over 0 factorial over 8 factorial. And you can see that 8 factorials will cancel each other out without doing too much effort there. And remember that 0 factorial is just 1. So 8C0 is equal to 1. And we can see it here on the calculator to confirm. I'm going to type it this time. You can just use your keyboard to type it in if you want to. And I'm going to go 8, 0, press return. And as you can see, I get the answer 1, which kind of makes sense if you think about it. Because we're saying I had 8 objects. I'm choosing none of them. How many ways can I choose none from 8? And there's only one way of doing that, and that is to choose nothing. It's still an event, it's still an outcome. I'm choosing nothing from the 8 in front of me, but there's only one way I can do that, and that's say nothing, thanks. Okay, 10C10 and 2C11. Pause the video, have a go at doing them longhand, confirm with your calculator, see where you go. Okay, hopefully you paused the video and did that. 10C10. Let's go straight into using the calculator. So we've got NCR. By the way, your scientific calculator also has these combination buttons. So just let me know if you can't find it. It's actually written as NCR above one of your number keys. Yeah, not surprisingly, I hope that's equal to 1 as well. Because if I have 10 objects in front of me and I need to select all 10 and order doesn't matter, there's only one way I can do that, and that's to pick up all 10. There's no other combination we can do. 2C11 is the last one. Let's put it into our calculator. NCR 2, 11. Capital letters don't matter. Press return. I get 0. Okay, so this is the one time where 0 is going to come out. And again, it kind of makes sense conceptually, I hope, that if I've got 2 objects in front of me and I need to select 11 from those 2, how many ways can I do that? I can't. It's an impossible event. So there are no ways of doing it. So it's a 0. Okay, so there's some combination calculations. Example 2 is just a very simple example. It's just asking you to find combinations of teams. So how many teams of 7 can be made from a squad of 11 players? So you would simply go 11, C, 7. So from 11, combine 7 players. And then you can go straight to your calculator and do it. Or if, let's say it's worth 2 marks, you could go 11 factorial over 7 factorial, 4 factorial. Okay, so all I'm doing is I'm writing down n, then I'm writing on r, then I'm going 7 plus quad equals 11, 4. So I'm writing 4 down, and then I'm going to do the rest on my calculator. So I'll go back to my calculator, NCR 11, 7. So 330 is the answer. So there are 330 ways or 330 teams I could make from 11 players. Okay, I'm going to leave this video here, and my last video on combinations will be for Thursday's lesson, and it will look at doing some more complicated problems, I suppose.